Section 9.3, Solving Quadratic Equations. Today we're going to look at solving quadratic equations graphically and through the use of the square root. Keep in mind that the standard form of a quadratic equation is ax squared plus bx plus c equals 0. The term root or zeros refers to the x-intercepts of your quadratic graph. And then in this case, the solutions of your quadratic equation are the x-intercepts of that graph. So roots and zeros are no more than just x-intercepts, which happen to also be the solutions to your quadratic equation. So to solve by graphing, all we're looking to do is find where our graph crosses the x-axis. So, first example, x squared minus 1 equals 0. We want to graph this to find our solutions to this quadratic equation. So let's just find some key points first. We're going to find our vertex and our axis of symmetry. So axis of symmetry, x equals negative b over 2a. In this case, there is no b, so we just use 0 over 2 times 1. Well, that gives us an axis of symmetry of 0. So our axis of symmetry is going to occur at the line x equals 0, which is our y-axis. Then to find the y value of our vertex, we plug in our axis of symmetry. Solve for y, well, we get y to equal negative 1. So that means our vertex is at the point 0, negative 1. So we can go ahead and plot that point. All right, and our axis of symmetry just runs through the y-axis. No big deal there. But now to graph the rest of this, we need additional points, and we can't use our y-intercept because it's already been taken through our vertex. So we're going to create an xy table, and you can do this using the table in your graphing calculator or by hand, and we're going to find the values that allow us to plot the rest of this parabola. Right now I already have the point 0, negative 1, and I want points on both sides of that first point. So let's say I use negative 2, negative 1, 1, and 2 to get some additional points here. Well, negative 2 squared is 4, 4 minus 1 is 3, negative 1 squared is 1, 1 minus 1 is 0. So right now I've got the points at negative 2, 3, and at negative 1, 0. And I know because of the axis of symmetry that my points for 1 and 2 will be mirror images of negative 1 and negative 2. So I've also got points here at 0 and 3. And so this is my parabola. And I happen to choose some good points here because I can actually see where my graph crosses the x-axis. It's right here and right here, and I know those values because they're in my table. And so my solutions are x equals negative 1 and x equals 1. If for some reason we didn't happen to see the points in our table, we can use our graphing calculator to find the exact location of our x-intercepts. And I'll show you how to do that in a different video, but for time reasons, we'll just keep to the basics here and do the entire problem by hand for the most part. So let's look at number 2. We've got x squared minus 25 equals negative 25. Well, first things first, we got to move this 25 over. It's in the wrong spot. So we add 25 to both sides, and I've got x squared equals 0. Well, in this case, I don't have any b value, and my a value is 1, so I know that my axis of symmetry is just going to be x equals 0, like the last one. Then when I plug in 0 here, my y value is also going to be 0, so my vertex is the point 0, 0. So in terms of my points, I start off with 0, 0, and I'll just choose points on opposite side. Let's just do 2 this time. We'll go negative 2 and 2. So negative 2 squared is 4, and then 2 squared is 4 as well. So we can plot these points. We've got 0, 0 as our vertex, and I've got negative 2, 4 is one point, and 2, 4 is the other. And so this is my parabola. And with this one, I can also see where my graph crosses the x-axis. It's right here, or at least where it touches it. And in this case, I only have one solution. And that solution is at x equals 0. Next example, I've got negative x squared plus 4 equals 0. So once again, we'll start off by finding our vertex. So we'll find our axis of symmetry first. So we've got x equals, there's no b value, so we'll take 0 over 2 times negative 1, or 2 times a. So our axis of symmetry is just x equals 0. And then we find our vertex by plugging in 0. So we've got negative 0 squared plus 4. So that means, in this case, the y equals 4. So our vertex is the point 0, 4. And so now we look at our xy table, x and y. We've got the point 0, 4. And we'll just try to choose some points on either side. Let's do like negative 2, negative 1, 1, and 2. Well, negative 2 squared is 4. Then you tack on the negative. So negative 4 plus 4 is 0. We've got negative 1 squared is 1. Tack on the negative. You get negative 1 plus 4, which is 3. And then 1, you get 3 again. And 2, you get 0. And remember, you can find these values in your table on your graphing calculator if you want, or you can do it all by hand. And so now we're going to graph these points. I know my vertex is at 0, 4, which is up here. I've got a point at negative 1, 3. I've also got a mirror image point at 1, 3. And then I've got negative 2, 0, and 2, 0. So this is my parabola. And once again, I was able to see where my graph crosses the x-axis graphically, and it was a part of my table. So in this case, my solutions are x equals negative 2 and x equals 2. All right, fourth example, we've got x squared plus 3. So same idea, we start by finding our axis of symmetry. So that's x equals negative b, so there's no b, over 2 times a. So that means axis of symmetry is just x equals 0. We'll plug in 0 to find the y value of our vertex. So we got 0 squared plus 3. So that means y equals 3. So once again, our vertex in this case is 0, 3. So now we just create our table of values. All right, and so we've got 0, 3 here. Let's just choose some points on either side. So we can go negative 2, negative 1, 1, and 2. So negative 2 squared is 4. 4 plus 3 is 7. Negative 1 squared is 1. Plus 3 is 4. And because of our axis of symmetry, these will mirror on the other side. So we're okay. So now we just want to plot these points. So 0, 3. Negative 1, 4. 1, 4. And 2, 7. And negative 2, 7. And this is our parabola. This time, however, we have no solutions because our graph never crosses the x-axis. So our graph never crossed the x-axis, so we have no solution. All right, so now that we looked at solving graphically, let's talk about solving using the square root. And so when you're solving using the square root, the idea is to get the x squared by itself, then square root what remains. And when you square root something, you want the positive and negative versions of that number. So in this case, they solved and they took the square root of 15, and their answer became plus or minus the square root of 15 since it was a decimal and they didn't want to simplify. If it's a perfect square, go ahead and square root it. All right, so we've got 3x squared minus 75 equals 0. The idea here is to get the x squared all by itself. So first thing we'll do is we'll move the 75 to the other side. So I've got 3x squared equals 75. And then I'll divide by the 3, which gives me x squared equals 25. My last step is to square root both sides of the equation, and I should get x to equal plus or minus 5, because 5 times 5 is 25, and negative 5 times negative 5 is 25. So these would be our two answers. Next example, 3x squared plus 15 equals 0. Same idea, we'll move the 15 to the other side, so we'll subtract it. We've got 3x squared equals negative 15. We're going to divide by 3 on both sides, and we end up with x squared equals negative 5. We're going to go ahead and try to square root this now that we've got the x squared all by itself. But when we try to square root this on our calculator says error, which tells us right off the bat that we have no solutions. Because right now, we cannot square root a negative number. So we have no solutions. And then our last example, we've got negative 16x squared minus 49 equals 0. We'll keep up with the first two examples. We'll move everything away from the x squared. So I'm going to add the 49 to the other side first. I've got 16x squared equals 49. Then I'm going to divide by 16 on both sides. I'm not going to divide this into a decimal or a strange fraction. I'm going to leave it as is for right now. Because right now I know that 49 and 16 are both perfect squares, and it's going to be easier to square root them as 49 over 16 than it will be as a decimal. So right now I've got x squared equals 49 over 16. So my last step is to square root both sides of the equation. And I'm going to get x equals, well, the square root of 49 is 7, and the square root of 16 is 4. So I've got x equals plus or minus 7/4.